Okay, so I'm going to be working with this equation here. We're going to be solving an exponential equation that doesn't require any knowledge of logs. This is all solvable or doable by just using our exponent rules, which we've all learned already. So what I'm going to do is I'm going to start by rewriting each of these expressions using the same base, because this method is sort of strange in solving an equation in that I'm going to try to make this side look exactly like this side. That's kind of my goal here. So I'm going to start by making everything have the same base. The base I'm going to use is base 2 because I feel like that's really the only one that's going to work for all of these. Although 4 seems tempting because we have a 16, I can write 16 as 4 squared, but 8 I can't really rewrite as 4 to the something. And so what I'm going to do is I'm going to go down to the smaller base and I'm going to use base 2. So let me show you what I mean. I'm going to rewrite this one as 2 to the third. So my 8 I'm going to rewrite as 2 to the third. So this is what I mean by changing it to something that has the same base. And that means I can also rewrite this one as 2 to the third because that has the same value as 8. Now 16 I can rewrite as 2 to the fourth. And now we have something where all the little expressions have the same base. Now what I'm going to do, again, like I said, I'm trying to make this side look identical to this one pretty much. So what I'm going to do is I'm actually going to keep rewriting them until they actually do have the same base. Right now, again, we still have this fraction. And what I want is it to say 2 to the something, not 1 over 2 to the something. So I'm going to rewrite this one as 2 to the negative 3. And if you remember from your exponent rules, of course, you know, the negative means raise the reciprocal. So this says raise 1/2 to the third. So this and this do say the same thing. Now this one I'm going to go ahead and simplify. And we have raising a power to a power. And if you remember when we raise a power to a power, of course, that means multiply the exponents. Now over here I'm going to multiply also. But keep in mind that I have to distribute when I multiply here. So this is actually going to be 2 to the 8 minus 8k. Now, in order to make these sides look the same, what I really want to do is have just one expression on each side. And right now you can see this one has 2. But I know how to multiply these together because it's 2 things with the same base. And when I have 2 things with the same base, all I have to do is add those exponents. Well, unfortunately, those exponents are not like terms. So I have a negative 6k and I have a 3. I can't really add those together. All I can do is let them sit next to each other, and we'll call that added together. All right, now this is where I've been trying to get to, because from here it's actually pretty simple to finish this up. If you look, we see that we already have a 2 here as a base and a 2 here as a base. So think about it for a second. If I had 2 to the third is equal to 2 to the question mark, you would know right away that that's a 3. That's the only thing that would make sense. So if the bases are the same, then that means these exponents would have to be the same also. So that same thing has to be true here. If these bases are the same, then these exponents have to be the same also. So how am I going to figure out what number makes them the same? I'm going to set up an equation and solve. This is what we do in algebra all the time. So I'm going to set these two things equal and see what will make them come out to be the same value. What solution can we get for k that will make these the same? So here we go. We're just going to solve this. Now this is something you know what to do with. You do this all the time. I'm going to start by adding 8k to both sides. And that will give me a 2k minus 3 is equal to 8. I'm going to add a 3 to both sides. And my last step is to divide both sides by 2. So we get k is equal to 11 over 2. And this is the value I could plug in to my original equation and get a true statement. So that makes it the solution.